Water is the single most critical input on a farm and often the most wasted. Today, I'll show you step by step how AI systems optimize irrigation schedules to save water and supercharge crop growth. This is practical, actionable, and used by farms worldwide. The goal is simple: deliver the right amount of water to the right spot at the right time. We'll walk through the data the AI needs, the models it uses, how it makes decisions, and how those actions are executed end to end. First, AI starts with data. Lots of it. Soil moisture sensors measure water content at different depths. Soil maps tell the system how water moves and is held. Weather stations and forecasts provide real-time temperature, humidity, and rainfall data. Drones and satellites look at the plant canopy to spot signs of stress. The system even tracks its own performance like flow rates and historical records. Finally, it knows the crop's growth stage, because a seedling needs different care than a mature plant. AI fuses all of these inputs to build a live picture of the soil, plant, and atmosphere. But raw data isn't enough. It needs to be cleaned and turned into useful features. Things like the average soil moisture per zone, or the root zone water deficit, which is how much water is needed to rebuild the soil. These features let the AI actually reason about when and how much to water. Now for the brains of the operation, the modeling and decision logic. A predictive model forecasts soil moisture for the next few days, using weather forecasts and soil drying rates. Another model predicts crop water stress, mapping moisture levels to potential yield loss if no water is applied. Then, an optimization engine gets to work. Its goal is to minimize water and energy costs, while keeping any yield loss below a set threshold. It considers constraints, like pump capacity or only irrigating at night. The engine then computes an optimal schedule: which zones to water, when to start, and for how long. It scores multiple options and picks the best one. Once a schedule is chosen, the system takes action. It sends commands to smart valves in the field, opening a specific zone for a set time. It can adjust pumps for variable rate irrigation, giving sandy spots more water and clay spots less. It can even trigger fertigation, applying fertilizer only where it's needed. Every action is logged for review. And of course, the farmer can always check in through an app to override or approve the schedule. This is a learning system. After irrigation, the AI observes the results. Did soil moisture hit the target? Did the plant stress level go down? Did unexpected rain cause overwatering? This feedback helps the AI update its models and improve its forecasts. The system literally gets smarter every single season. So how do you know it's working? You track the key metrics: water saved compared to your old manual schedule, changes in crop yield or quality, and of course savings on energy and labor. Good systems regularly report 20 to 40% water savings, with more stable or even increased yields. Let's make this real with an example. Imagine a field with two zones. Zone A is sandy and dries out fast, so the AI schedules short, frequent watering cycles at night. Zone B has heavy clay soil that holds water, so it gets fewer, longer cycles. Suddenly, the forecast shows rain coming in 18 hours. The AI automatically skips irrigation in the affected zones, shifting that water to others. This is how you get targeted watering, lower pump run time, and a healthier crop. Ready to try it? Start small, with just one field. Use a few well-placed sensors per zone. Pair those soil sensors with drone or satellite imaging for the best results. And make sure to review the AIS suggestions each week. It's not magic. AI-driven irrigation is about making smarter decisions with better data. It helps farms use less water, spend less on energy, and protect their yields. Thanks for watching. If you found this helpful, be sure to like and subscribe for more content.